Hi everyone, Electro here. I'm just going to check the dimensions of the distribution cavity, and in particular the relationship of the top of the disc to the opposing platform there. Before I go whacking any gases or anything through this, it's important to see that all those things are correct, because if, say for instance, the disc itself is sitting off at an angle, that means that there'll be space on one end and not on the other. It's not a good situation to have. It's better to know all that beforehand. So how I'm going to do that is by using a silicon. This is a two-part mix. It's a quick setting silicon. It's also non-adhesive, which means it shouldn't stick to the opposing surfaces. So what I'm going to do actually is just mix it up. Like I said, this stuff sets pretty quickly, so I've got to work fast. There. Now I'm going to screw that on. And there you go. Oh, just make sure it's all still centered. Everything looks right. Now we just wait for that to set. What I'll use is the material left over on the spatula and the pad to see when this sets. That's when I'll take the spark plug apart, and in the meantime I've got one that I've already done, sort of. This is one I was playing around with. This is what I should get. Now what that will show me, as I said, is the relationship of the disc to the opposing platform. Now if there was a space there, you'd see silicon more left over. Now there was silicon here, thin silicon like there is there, but it came off when I unscrewed it, but I could see it was there because the pieces were floating around. I've just since removed them, so that's why they're not there at the moment. But that did indicate an even contact. This disc, however, is not set yet, and neither is the electrode, so this was just one to see if it would work. The other thing that it showed me that is quite important is the thickness of the distribution cavity. Now there it is there. I can take that off. Now I can measure that and get the thickness of it. And being rubber, it's resilient and it'll hold its shape. So it means you can measure it quite easily compared to conventional materials, which some of them are like plasticine, which is, they work the same way, but they're easily deformed, and once they're deformed you have to retake the measurement again. So this is a bit more robust, it works a bit better that way. So anyway, we'll see how this is going. It's still a bit tacky, but it's setting quite quickly. The other advantage to this, in particular in my situation, normally I suppose you could get a O-ring machined in around there, so you can, once you put the other housing on, it'll seal there. But in this case, I haven't got one, and I tried using plumber's tape on the thread. But what happens with that is it bunches up, and because this is dependent on metal to metal contact to achieve a consistent gap in between the pieces and consistent position, if that gap's disturbed, you'll lose your dimensions, and it's not reproducible. So, in other words, I could use this stuff, just a little bead around the bottom there. So when I screw everything together, it'll still seal. So when I put everything under pressure, nothing's going to leak, because I've tried that, and I had leaks around here. And I had some around here, but that's where I put plumber's tape on these ones, because they don't matter. But this one does, and that's what I found. Like the distance in the on the top there will vary, And actually this was the technique that I used to suss that out, and lucky I did, otherwise it okay, now that's just about set. I might give it another couple of minutes because it'll defeat the purpose if I do it too quickly. Another thought I had about changing the dimensions or the volumetric amount of the distribution cavity is using spacers. This particular one is 0.6 millimeters. A staple, just a normal everyday staple, is that just bent up. That's 0.5 mils. Now, if I put that there, or on top of this platform, between that or the jig or whichever, but that'll hold a consistent difference between this platform and the opposing platform. I can set the disc to that dimension, really, or to that distance, and I can vary the protrusion of the disc by the spacer that I put in there to an accurate degree. That'll give me the ability to play with increasing and decreasing the volume of the distribution chamber. Now, that may do something, it may do nothing at all, but it was just a nice feature to incorporate in the design anyway. I mean, while I'm making it, I thought about that, so why not make it like that? It just gives me more flexibility. Now, okay, this should be set. Feels good so far. There it is there. And as you can see on top of the disc, there's those rolled pieces that I was telling you about. So that looks like it's got nice even contact there. Now, being silicon, non-stick silicon, this should just rub off. Well, anyway, as you can see, I'll be able to get that off. I'll do that later on. Here's the important piece. It's gone up inside the walls. Sorry, up inside the holes. I'll have to dig that out. Okay, so that will give me, oops, sorry guys, there you go. That's the thickness of my distribution cavity around the disc itself to the edge. As I've just got to remove the excess there. I'll just get in there with a pair of tweezers later on. Also there, I'll probably just hit that with a brush. That'll get rid of all that. So there, but that tells me the top seals. There's I'll be able to measure that, but that looks about the dimension that was stated in the drawings that Russ Grease supplied. So far so good. But anyway, if it's not, it's quite easily adjustable now. So there you have it. Anyway, post your thoughts. Bye for now.